Welcome to Math 1960 Calculus 2, UNO Summer Session 3. In this lecture, we want to find a volume of a solid by using the slicing method. So, if you have a volume which is not necessarily a solid of revolution, you can slice it using perpendicular planes that are perpendicular to x-axis, and then slice out infinitely this shape. Find the individual volume of the slices and sum them up. So, for mathematically, this would be like finding the cross-sectional area of one of them, right, as a function of x, and then integrate that cross-section. So, this is an example. We want to use a slicing method to verify that the volume of the right circular cone, which has a radius of r and a height of h, is equals to that volume. 1/3 pi r squared h. So this is a right circular cone. Okay, if we took a projection, side projection to this, we find a triangle like this. So two triangles, two similar triangles. So now, using the method of two similar triangles, r divided by x must equals to capital R divided by h. This is true in similar triangle. That means R is equals to capital H times x. So what is R anyway? This R here is radius of this circle. That means a of x, right? So it's going to be equals to pi, right, times the radius squared. This is the radius here, so it's going to be equals to r squared x squared divided by h squared. Okay, now in order to find a volume using a slicing method, all I need is these a's of x, and then I can integrate a's of x, find the whole volume of the solid. A to b a's of x. That's what the formula says. Okay, what is a here? A is the first point. B here is the final. So we're going to integrate a equals to 0, a equals to 0 up to h. Right, this is h here. Of what? Of pi r squared x squared over h squared dx. Here we. So now when we take the integration, so the only thing changing here is x, right? So when we integrate x, it's going to be x cubed divided by 2. Everything else is constant. So pi r squared h. Sorry. So uh, we evaluate that from 0 to h, 0 h. So then now when we substitute in, we're going to get pi times r squared. When we substitute here h cubed divided h times 3, then times h squared. This is h squared. So h squared is okay. Then the final answer is 1/3 pi r squared h. And that is exactly what we saw earlier. Okay, a solid has a circular base of radius 3 units. Find the volume V of the solid if every plane cross-section that is perpendicular to a fixed diameter is equilateral triangle. So obviously this is the shape we have, and then we are slicing it up in terms of triangles, and each and every triangle is equilateral triangle. So that means this is an equilateral triangle. So we take this, this triangle. Here is 2y, here is 2y, here is 2y, and then now using Pythagorean theorem, we get h squared is equal to 3y squared, and then h is equal to that. All right. So how do you find the area of a triangle? Well, area of triangle is 1/2 base times height. That gives you that. So the base is going to be 2y, okay, and the height here is square root of 3y. Then that's what you get as the area of the triangle. So since we want to use these formulas, so integral from a to b, a of x, so we're going to translate that to x. So that means, we know y squared plus x squared is equal to 9, right? This is equal to 9. X squared plus y squared is equal to 9. This is a circle, right, with a radius of 3. Okay, that means y squared basically equals to 9 minus x squared. So then, now we're going to change y squared here in terms of this, and then we say the volume b is integral from -3 of square root of 9 minus x squared dx. Okay, so now this is basically, this is equal to 2 integral from 0 to 3 of square root of 3 9 minus x squared dx. So then it's going to be equal to 2 square root of 3. So then we're going to get 9x minus x cubed from 3 evaluate from 0 to 3, and then so then now we evaluate this. we're going to get 2, so 2 square 27 minus, this is 27 divided by 3 is going to be 9. So then the volume be 9 minus this is 18. 18 times 2, that's 36. That's cubic units. So to find the volume V of a pyramid of height h with the square base each side length b. So this is the shape we want to find its volume. So this is the area, cross-sectional area of each and every slice, and then in order to find the volume, we multiply that cross-sectional area delta x, right? That in terms of integration becomes like this integral from 0 to h, all right? 0 is going to be here, and then here h, right? Integration of what? B squared squared x squared dx. Then when the integral that is going to be equals to b squared cube h squared. Evaluate that from 0 to h, times 2. And then going to get 1/3, so b squared h. That is the final. So it's going to be 1/3 b squared h cubic units. So we are going to discuss how to find the arc length of the graph of a function y. To find the arc length graph of a function using partitioning of y. And then we will also find the surface area of a solid solution. In order to find arc length, so first of all, we want to find the length of this curve. That's right. So in order to find the length of this curve, first we want to come up with a line segment, right? That almost approximately give me the length of this segment. So then we sum up this line segment that gives you the approximated length of the arc. However, if we make this line segment very, very small, then infinite number of times then the arc length. So this is basically how we can calculate the arc length. So the derivation is very long. So, but it's really something somebody can follow. It's easily can follow it. So the arc length usually, if we are partitioning x-axis, is given by this. Okay, it's given by this formula. So first of all, the component of the formula, a to b is the interval at which function is the interval at which the function is being assessed, is being its length is being calculated. And here I have f prime of x, which is actually like the derivative. Okay, so the function has to have a derivative for us to find the length, and it has to be a continuous function on the interval a and b. Also, we can find the arc length for a graph, right? For a graph. So for a function defined by x equal to g of y, this I call it a graph because a graph which says x is equal to g of y. G here is continuous on c and d, and then g prime is available. We have g prime, right? So this is no different from what we saw earlier. Here, we are integrating in terms of y, right? And what we are partitioning is y, right? Also, finding the surface area of a solid of revolution. Can use the arc length times 2 pi f of x. That gives you surface area, right, of a solid revolution. So here in our find the arc length of the graph function. So this is the function I have to find the arc. How do I find the arc? S is equal to integral a to b, right, of square root of 1 plus f prime of x squared dx. So f prime x. So f prime of x, if we have ln of x, usually it's going to take f prime of these in a function divided by the function itself. That's going to be secant x times tangent x divided by secant x. Secant of x cancels out. F prime of x is equal to tangent x. So a equals to 0, b is equal to pi. So then we say s is equal to integral 0 to pi 4 1 plus and square of x. Okay, so integral 0 to pi 4. So 1 plus 10 square of x is equal to secant square of x. Secant square of x. Then when we take the integration, it will be integral 0 to pi 4 of secant x. And that gives you, so s is going to give ln of c x and x. So we evaluated 0 to pi 4. Then when we get ln to square root of 2 plus 1. Okay. So example number 2, we want to find the arc length of graph of function. This is the function that extends from 2 to 8. So first, to find the length the graph S to integral a to square root 1 plus f prime of x squared. So then now find x of this function. So we bring down the exponent, we subtract 1 from the exponent, negative 1/3. And then, so then we say s is equal from 1 to 8 of integration 1 plus 4 9 x raised to power 2/3, right? dx. That is going to be integral from 1 to 8 of 9 x raised to power of 2/3 plus 4 divided by 9 x raised to power of 2/3 dx. And then take the 2/3 out. Then we say s to integration from 2 x raised to power of 1/3. So 9 x raised to power of 2/3 is 4 x. And then now let's take u equals to substitution equals to 9 x raised to power of 3rd is 4. Then we say it's equal to 6 x raised to power negative 3rd negative dx. So then we can say du 6 is equals to x raised to power negative dx. So then now with substitution we say s is equals to 13 up to 1 raised to power du over 6. That gives 13 up of 1 over 13 and raised to power 1/2. That gives you 127. 13 raised to power 2/3 minus 50 raised to power 2/3. Sorry, 3 over 2. 2, 2, 2, raised to power 2. That should be answer. Determine the length uh, of this arc. Right? This is a function in terms of y. Want to find the length. So first, s is equals to integral c 1 f prime y squared. So so prime f prime of y. Then have prime 2. Then y minus raised to power this cancels. Then s from 2 of square root y is 1. And integral of n. So when the integration should get integral of y versus power values 2, and that should be equals to t. That's the final answer. So we want to find the surface area as solid generated by one by the graph of y square root of x, x-axis, and x equal to 4. So first we have a surface and we want to find the surface of revolution. Okay. Alright, so first what we're going to do to the surface of revolution as the following, right? So it's going to look something like that. This is the surface revolution. We want to find surface area. So surface area of that it's given by this formula. Um, so if you call it A is of uh, A is going to be equals to 2 pi integral of A to B of f of x squared 1 f x squared x. So first, the function we have is f of x equals to 1 half, and f prime of that going to be 1 half x raised to negative 1 half. And area is going to be 2 pi negative 1 4 x raised to the power of 1 half negative 1 4. So and then uh, cosmetic change uh, 4x x 2x is 1 to 4x, and then say a is equals to integral that which is point from 5 to 17 is f du4, and that should be 6 17 raised power 3 minus 5 raised power 3 over 2. That should be the area.